want to set up bogeys 135, 50, Angel 16.
Forward side, high, coming down hard.
Roger. Down to 3,000 here, Munster.
Since it was first fielded in 2006, the F-35 has become the premier fighter jet for the U.S. military and more than a dozen of its allies around the world. It flies and operates on the strength of a single engine, the Pratt & Whitney F-135.
I grew up flying twin-engine tactical fighters, so we always had redundancy in the propulsion realm. Going from those airplanes to an F-35 for a Navy fighter guy was, hey, this is a single-engine gig, and you know we're going to be flying it out blue water ops, which means we're launching and recovering on an aircraft carrier with nowhere else to go. That gives you a little pause. As I was able to fly the airplane, learn the systems, I quickly built trust in the propulsion that's in the F-35. I never had propulsion issues. I never had propulsion issues.
The F-135 engine was built specifically for the fifth-generation fighter jet, with more than 500,000 hours of safe operation to its credit. Its reliability comes in part from its history. It is based on the F-119 engine, which was developed and proven on the F-22, a twin-engine fighter.
We don't field brand new technology on single-engine fighters. We field it on twin-engine fighters. We learn out the technology, and then we take derivative technology and put it on a single-engine fighter jet.
The current F-135 has accumulated more than 600,000 flight hours. It has the best safety record for a single-engine fighter. Its reliability is fully meeting our requirements, and the cost of acquisition and the cost of sustaining it has continued to come down year over year.
There have been 3 major upgrades to the F-35 totaling over $7 billion, but the engine itself has never been modernized. The next F-35 upgrade, known as Block 4, is scheduled to come online in 2028, and it's going to continue to push the engine beyond the original specs. There are 2 main options for a more powerful engine: upgrading the F-135 or replacing it with what's known as an adaptive engine, a completely new technology.
We firmly believe that upgrading the existing engine is the right solution, and a new engine is not the right solution. What matters to the warfighter is getting as many Block 4 enabled jets fielded as possible. From a taxpayer perspective, an upgrade to the existing engine costs a fraction of a brand new engine, and that's both near-term and long-term.
The adaptive engine holds great promise, and Pratt & Whitney engineers are currently developing one. But they believe that it will best serve future twin-engine fighters, not those that are already flying, like the F-35.
The right time and place for incorporating the adaptive engine is to the 6th gen future fighters. And we believe that the F-35, which is a weapon system that's performing well, the right application for that is the engine core upgrade.
The engine core upgrade is a drop-in solution, meaning it can be integrated directly into the jet without requiring major modifications.
It's low risk, it won't disrupt the program, but it'll enable the warfighter to fully employ all the capabilities needed to be operationally ready for any threat environment.
And it is the only solution that will field fast enough in meaningful quantities to make a difference for the warfighter.
The derivative that we're bringing forward with the engine core upgrade, it's the most expeditious path to enabling Block 4 and delivering a capability that is unknown today, but undeniably needed in the future.
Keeping the F-35 dominant for decades to come will require more than an engine upgrade. The jet will also need an improved cooling system to manage the heat from its growing list of electronic systems.
On the F-35, there's a significant challenge today where the aircraft has reached the limit of the capability of the cooling that they have on the aircraft, but they still want to add more equipment. You're adding additional heat that wasn't there before, and we need to be able to provide capacity to cool that heat.
Cooling helps keep the F-35 operational. Cooling systems work by using compressed air from the engine. But when they use too much of that air, also known as bleed air, it affects the engine's ability to perform.
So bleed air is really taking away power from the engine. We need it to power those systems, but every pound per minute of air that we draw off those engines is a pound per minute of air that is not going to the turbines. It is not creating shaft horsepower, or it is not creating thrust.
When you pull bleed off of an engine, that has a cost. It has a cost in performance of the engine, or it has a cost in the life of the engine. So you want to make sure that your propulsion system, your engine, your motor, is designed to work hand in hand with your power and thermal management system.
So it's causing the turbine to wear out sooner. The more often you have to repair the turbine, the more money it costs, the more downtime for the engine, things that the warfighter doesn't want.
And the only place they can go is larger heat exchangers or more bleed extraction from the engine. Both of those are going in the wrong direction for the performance of the overall aircraft system.
To solve that problem, engineers at Collins Aerospace have developed the Emergency Power and Cooling System, or EPACS.
Our emergency power and cooling system can operate very efficiently with less bleed air. We still can provide the level of cooling and power thermal management capability as is required through the life cycle of the F-35. But what that means for the warfighter itself is not only improved capabilities of the actual aircraft, what it also means from a maintenance standpoint, there should be reduced maintenance costs, there should be longer engine life, and ultimately should improve range and thrust.
As a pilot, I never really gave two hoots about cooling when I was flying older airplanes, but cooling has always been a critical part of growing mission systems in any airplane.
The engine core upgrade and the Emergency Power and Cooling System both bring benefits to the F-35, and together, they would unlock the fighter jet's true power.
The opportunity that we have as Raytheon Technologies to work on both the engine core upgrade as well as the emergency power and cooling system gives us a huge advantage of being able to bring those technologies together in the most efficient way possible.
The power of combining the F-35 engine core upgrade with the emergency power and cooling system and the ability that Pratt & Whitney and Collins bring together under the Raytheon Technologies umbrella is that you get a system that's optimized.
This solution creates a faster, less expensive way to get the F-35 performing to its potential.
It solves the power and thermal management challenges in the most cost-effective way. And above all that, it is the only option that preserves tri-variant commonality and preserves the international alliance that is really the hallmark of the JSF program.
For the F-35 program, it's a no-brainer. It wins on cost, it wins on schedule, and it's a performance winner as well. The warfighter's gonna love it. You remove it from their worry list. Why would you choose to do anything else?